Max Coin News MCN. Yes. Okay, hi guys, welcome back to my channel, Max Coin News. I'm Max. Today we're going to have some fun with this game. Max, oxygen not included. Rocket automation. So I have built this rocket here, not so big, just a couple level, like 6 levels of rocket. And I have, of course, with debug mode, yeah, and then I uh, make some little bit automation here to automate the launch and also the arriving. And let's discuss a bit about the fuel production automation. So basically, right under my base, I have built this thing. Yeah, I mean the fuel production for the rocket, liquid hydrogen and liquid using liquid hydrogen and liquid oxygen. Initially, gas from this electrolyzer room with pumps and so on, and I separate the gases uh, between hydrogen and oxygen. As you can see, this thing is uh, this producing electrolyzer producing hydrogen gas and oxygen gas, and then I use filter to separate the oxygen up there, also up there, with and also get some pure hydrogen, which I put on in this room here for the hydrogen, and this room is for oxygen, and I put that gases oxygen to the cooling system here, the cooling section. So basically I use liquid cooling system uh, using this super coolant, which has uh, very wide range of uh, cooling. I mean, it can hold until minus 271 degrees Celsius and before turned into solid, and then maximum like 436 degrees Celsius before turned into gas. So this is a special liquid for cooling system, or you can use of course another liquid, but this one is very good to for cooling system. So what I did basically, I circulate this super coolant here with this liquid reservoir and also this liquid shut off, and to this additionally I put thermocol tuner to cool down the liquid. So here you see, and I put sensor here, so basically it just circulating like that, and when the temperature get higher because of the cooling, it will activate this pump here and disconnect the set off here, the automation of course, you see. So if it's above the liquid temperature of oxygen, this is for oxygen here, oxygen cooling system. If it goes above the liquid temperature for oxygen, it will activate the aqua tuner here and cut the gas system here. So you see this circulating through the set off, and if it's activated here, and this will disconnect and it will circulate through the aqua tuner to reduce the temperature. So basically that's the principle, and I use insulated pipe here to maintain the temperature and radiant pipe on the special section here just to dissipate the coolness. I mean to take the heat from this room to make it even cooler and cooler. And then, as you can see, the oxygen is, you have to reduce the temperature on this room until minus 183 degrees Celsius. So so this machine here will keep cooling the supercoolant until minus, I put it here more than minus 183, like 175 here, just to make sure it cools down the oxygen that come into this room. And then, as you can see, the gas system here, I will just pump this oxygen into this room, and then it will start to go, the temperature will go down into minus 183 degrees, and then after that it will drip down as a liquid like this. You see it drip down, and then after I collect some drops here, I will pump the liquid into the main reservoir here. This is for liquid oxygen. You see, minus 188 degrees, very cold. And this one is for liquid hydrogen. The hydrogen is producing a little bit less, as you know that electrolyzer producing more oxygen than hydrogen, so you get much more less hydrogen rather than oxygen. So I have to build, I just make this like 7 electrolyzers with 14 pumps here, and also some filters and so on from this, and then I get some just a little bit hydrogen and oxygen. But yeah, basically that's all the principle. The same works as the hydrogen cooling system here. I use liquid to cool down this room, and then just pump this gas to this particular room to get some hydrogen drip. Why doesn't work? Okay. So same principle, I mean, this one is using this shut off and then the automation. This one, but hydrogen is much more, has a lower liquid temperature. It has to minimum goes until minus 252 degrees, a little bit extreme temperature, and I set here just minus 270, or maybe like 65 is already okay. And then after it keeps cooling down this part here with radiant pipe, it will cool this specific part, the metal plate here, and then I just pump my gas hydrogen into this part, and with hopefully this will cool enough to turn the hydrogen gas into liquid form. And then after I get some drips, I just pump that to this particular reservoir room or container room or something like that. And then I also add some extra cooling system here. Same principle. I just circulate this super coolant thing, and then with the super coolant, I make radiant pipe here, just specifically to dissipate the low temperature, and then if it going hot, it will automatically the sensor that it will shut off this and then activate the aqua tuner here. So this has to reach like minimum 250 minus 252 degrees Celsius to actually make turn the hydrogen gas into liquid form, and then we can make fuel from that for our rocket. So this one is not cool yet. We have to fast a little bit. Not cool enough for the hydrogen. For the oxygen is already cool. This is liquid temperature. This one is not yet. Damage overloading. Oh, you mean electricity maybe? Oh, that one is open. So this moment I repair the cable there because our machine a bit overloaded. This one is not cool enough, so but this one is already cool. So as you can see, this is more than 252, like 269 minus 269. So it dipped down the liquid hydrogen here, and I just pump from this reservoir into our rocket above. See, I just pump this to liquid oxygen as the oxidizer, and then liquid hydrogen as the fuel. This is a little bit wrong position actually. It should be lower than this position. Maybe better around here or something, or here. Or if you want to make it far from your base, you can place here. Doesn't matter because this is scorching hot temperature around this rocket. Okay, now let's talk about this rocket. So basically, I pump this liquid hydrogen and oxygen into the rocket tanks, fuel tanks. I mean, and then after it reach some point, it will able to reach its destination. For example, I set the destination to this planetoid, the oxidized planetoid, to collect some rust or maybe other planets. And then what I did for the automation was that uh, that this one has a gantry here, like a platform. It has to be retracted when the rocket launch, and also retracted for a couple seconds when the rocket arrives. And also we have gates above here, so the gates has to open when the rocket launch, and also open when the rocket coming back or arriving. So I'm using this gate here, filter gate, and also buffer gate, and some couple ore gates here, and also for course the scanners here. Like this space scanner, this is for detecting meteorites, and the scanner here is for detecting incoming or outgoing rocket. Our rocket here, Space Explorer Hydro. So let's talk about this this small automation here. So basically, this rocket on the command capsule here, it has two one input and one output. This output will give green signal output when the rocket checklist here is complete. For example, our refueling is not finished yet, so it cannot reach its destination. But once this checklist is complete here, like the astronaut and atmosuit and others, once it's complete, it will give a green signal, and then of course it's ready to launch, just like that. And also, so I use this as the main trigger to automate the system. So once the checklist is complete, we'll give green signal up here, and then also here. Up here is to open the gate. I mean the bunker gate above. So green, this one green. Then it will for order the bunker gate here, bunker door. I mean to open all of them. And then this one is filter, so it will give some time for the bunker door, 35 seconds, yeah, to open the door completely. And then after it completely open, it will give green signal output, which is a launch, which means it gives a launch order or launch signal to this input in the command capsule. And also you have to don't forget to retract the give some signal to the gantry to retract back. So this one will give green here and also green to the buffer here around 10 seconds just to retract the buffer. So after it's complete here, it will initiate launch and retract the gantry, also open the gate, just like that. This one will also give green signal here when it's ready. Once this get green signal, this one will give also green signal, meaning outcoming rocket. Rocket is launching like this here. This one will go green just to make sure that I connect this, just to make sure the the bunker doors above here get green signal. So I just make this R to open the gate and also to make sure the gantry is detected. So a double mechanism here. The signal from here will function also. But why I make a double like that? Because actually there's two cases here. The launching rocket and the incoming rocket. So when the rocket coming back, when rocket coming back, then the scanner here will give green signal incoming rocket, and then it will force the give green signal here, and it will force the gate or the bunker door above here to open, and also green signal to the buffer here, which gives green signal to retract back, retract the gantry to allow the rocket to arrive. And then after that, 10 seconds later, I mean after it settle down, this will off, and then 10 seconds later the gantry will open out, just like that. So Let's fast forward a bit to refuel, wait the refuel to finish, or just change destination maybe. Uh, for example, this one, let's change destination to this one, and then as you can see, the checklist is complete, and then this one give green signal, so let's see, let's connect this. This one will open the gate, and for 35 seconds, this will delay the signal, filter gate. Just make sure the gate will open fully in that 35 seconds time. Okay, and this is counting down 35 seconds, and then it will give launch signal, initiate launch, and retract the gantry. You see, initiate launch, retract the gantry, starting the engine, and so on, and it will launch smoothly. Okay, that's the launch automation. I just disconnect this to show you that once the checklist is complete, it will automate to launch just like that. So now let's try to, you see there's no meteorites, the sky is clear. Let's try to call the rocket back. As you can see, this one will give green signal, incoming object detected, green signal, and then force this bunker doors above to open, and also retract the gantry here. You see, red signal. Let's wait for the rocket to arrive fully and safely, and then it will give off signal, red signal back. See, after it finish, this will off the signal, like that, and then it start counting down 10 seconds to open the gantry, and then replicants can go out. You see? Okay, that's the mine automation. The cargo is also automatically unloaded here with this conveyor rail. So this is basically the automation rocket principle. I mean, this way you just have to control about the fuel production and so on, and to make sure there's no entombment on this area and also on the rocket area here. Other than that, you can select your destination anywhere and collect those materials from those, like this here, crust and carbon dioxide, just to exploit the other planets like that. Using this hydrogen rocket, one solid fuel thruster, you can delete this if you want to make more simple. Liquid oxidizer tank, which is liquid oxygen tank, and 3 hydrogen tank. So in total, this will be 2 point, sorry, in total 3 liquid fuel tank hydrogen, 1 solid fuel thruster, with iron and one solid fuel test oxalate and one liquid oxidizer tank oxygen. So in total around 2.7 tons of liquid oxygen and also 2.7 tons of liquid hydrogen plus this solid fuel thruster. You can change this cargo bay into another thing like um, sensing module or biological cargo bay is also very good to collect some unique animals or unique plants, seeds and so on. And also research modules is important to collect some sort of information about uh, this one, atmospheric, subsurface, surface and so on. And yeah, that's all my presentation about automation rocket. I hope it's useful for you and